Hey guys, in this video we're going to be going over separation of variables, which is pretty important to Unit 7 and is the main point. So basically how this works is that we know dy over dx is equal to our derivative, but if we have the issue of it giving us y variables like 5y plus 6x, the way you can solve this is by getting the y on this side, keeping the x on this side, then multiplying the dx. So you'd be like 5y dy equals 6x dx. And now what does this look like? This looks like something that we can take the integral of, because it's the dx with respect to y and dx with the respect to dx. Now this is pretty simple. You just end up with y squared over 5 equals, y squared over 2 times 5, and then 6x squared over 2. Just be 3x squared. Okay, and now you want to solve for y on its own. So what do we have to do? We have to times this by 2, divide by 5, and then square root. So you end up equaling y equals 6x squared over 5 square rooted, and that would give us our y variable. So it's a pretty easy thing, but it can get complex in the long run. So we'll go over a couple more problems and see what it looks like. For this one, we will look at some trigonomic identities. So sine theta dy over d theta equals cosine theta. Okay, so this one's a little bit more tricky because you don't really have a y variable to get. So what you're going to end up doing is you're going to get these thetas on the same side and you get dy. Okay, so now let's solve to get y by itself. So to do this, it's just divide by sine. So dy over d theta equals cosine theta over sine theta, which is equal to cotangent theta. And then we're just going to times this over here. Dy equals cotangent theta with respect to theta. Now you can integrate both sides. The integral of dy is just straight up y, because you know the derivative of y is dy. And then that will give us, this is just a trigonomic identity that you have to know, that we went over in earlier videos, and it's just the natural log of the absolute value of sine theta plus c. So this will give us our indefinite solution or general solution for the equation. Okay, now let's try a little bit more of a tricky problem. And for this one, we'll have x squared minus 1 y prime equals 2x over cosine y. Now this may look tricky because you have no dx to deal with, but all you have to remember is that y prime is just equal to dy over dx, and then from there it's pretty simple. Okay, so now what are we going to do? We're going to divide by this times by this, so you get cosine y dy, equals 2x over x squared minus 1 dx. Now we will integrate both sides, and that will end up giving us sine y equals, take out a 2, be x over x squared minus 1, which will make it, which will leave us with ln absolute value x squared minus 1 plus c. And now what do we need to do? We need to take the inverse sine to the negative 1 of both sides, and that'll leave us with y equals sine natural log x squared minus 1 plus c. Now the c can be on the inside or the outside because it's a constant value and it's just going to change with that, and it'll just move the graph up or down. Either one's right, but in general you can put it on the outside or the inside. Okay, now let's go one step further, and that's solving for the full equation, so solving for c afterwards. Okay, so for this one, we'll have dy over dx is equal to y over 2 root x when y of 4 equals 1. So how is this going to play over the long run? We don't need this till later. So first, let's just solve for the general solution of this. And to do that, we're going to times over the 2 root x. So 2 root x dy dx equals y. And then times that over, so dy dx, and then divide. Or you can just divide by dy, and you'll be left with 2 root x over dx equals y over dy. Now, we haven't really seen something like this where y is over that, but really you're just going to put 1 over whatever you get. So what this will end up looking like is 1 over, so the integral of 1 over 2 root x dx equals the integral of 1 over y dy. Okay, from there on we solve, we put the 1/2 on the outside. This will end up being x to the negative 1/2. So we'll add 1 to that. I'll put another 1/2 in front, so that'll be 1/4 x to the 1/2 equals, and then this is negative 1, will be ln y. Okay, so now what do? You take, oh wait, my bad. On this one, we'll put the 1/2 on the front, so it'd be 1/2 over 1/2. So this would be 2 over 2, which will just cancel out. So you'd be left with that. Okay, so now let's raise both sides to the e to make this y on its own. So y equals e to the square root x. Okay, so now we have our general solution, which is this. And we need to go back up here and realize y of 4 equals 1. Okay, so these are the two things we need to know. And from there, we're just going to plug in and solve. So y of 4, so 1 equals e to the square root of 4 plus c. Okay, so 1 equals e to the 2 plus c. And then we'll subtract e to the 2, subtract e to the 2, c equals 1 minus e to the 2. Now the reason this works is because e to the 2 is a constant, it's not e to the x, so it is a variable. So now we'll go add it all together, so we know our general solution is y equals e to the square root x plus 1 minus e squared. And that will give us our final solution. Okay, now for our last problem, this is just going to be a more trickier version of what we just did. So we have e to the x minus y dy dx equals 0 when y of 0 equals 3. So we're just going to subtract over e to the x, negative y. We'll just times it all by negative to make it simple. So y dy dx equals e to the x. Then dx times over here, this cancels out. And then y, so the integral of e to the x is just e to the x. And then y squared over 2. Then we will divide this by 2, square root it. Y equals square root of e to the x over 2. Okay, that's our general plus c, of course. Now that we have our general solution, we got to plug in this up here. Now, it might be easier just to use it from the equation over here, like our original one, where it was 1/2 y squared equals e to the x plus c, because then we don't have to deal with tricky square roots of 1/2 and all that. So now we're just going to plug in from here. So we will get 1/2 3 squared equals e to the 0 plus c. E to the 0 is 1. 9 over 2 equals 1 plus c minus 2 over 2, because that's 1. And you'll be left with 7 over 2 equals c. So now we plug it in over here. We know what our c is. And the final solution is y equals square root . Oh, okay, we made a mistake here with divide by 2. It was times 2. So this was supposed to be 2. Okay, so 2e to the x plus 7 over 2. This is our final solution. And of course, this didn't make a mistake when we did it over here because, we went from the original solution. Okay, guys, I hope you enjoyed this video. This is a general premise, and most of the time it just works by getting all the y's on one side, all the x's on the other, then multiplying over dx, and you're left with dy, and then from there you can just plug and chug. It's not that complex, and sometimes your constant will be an e to a value, and it really depends on your teacher if they want you to plug that into a calculator or leave it as is.